Okay, we are on 4.6 part 2. This is graphing tangent, cotangent. So much like we did on sine and cosine, we're going to just make a table because it's asking us what are some of the key points for tangent. Um, and then, where do they have an asymptotes and zeros and outputs of 1 or 2. So we're going to make a table to find all that information. And just like before, we're going to go x and y are inputs and outputs. And we're going to pick the angles negative pi over 2. We're going to go negative pi over 4. We're going to go 0. And we're going to go pi over 4. And we're going to go pi over 2. Okay. You might say, well, why did you pick those angles? And let's look down here. Mainly because in the case of tangent, cotangent, well, same thing with sine and or cosecant and secant, but we've got the asymptotes, and the period for tangent and cotangent is pi. Okay, and we want to make sure we get all the positive and negative values. So we actually are going to look in this world here, and when we look at pi over 2 or negative pi over 2, if you take the tangent of either of those, and I wrote this one incorrect down here. This should be 0, negative 1. When you take the tangent of either pi over 2 or negative pi over 2, it's undefined, which means we're going to have an asymptote. And then as we go through, as we move through here from this negative pi and we head towards 0, we're getting all of these positive x values. I'm sorry, we have all these are negative outputs, but they're all heading towards 0, and then we get here, then they're all positive heading towards 1. So anyway, let's fill in our after. So negative, this is undefined. Okay, and we're going to have an asymptote there. It asks about asymptotes. Okay, and then at negative pi over 4, right here, this would be root 2 over 2 and at negative root 2 over 2. Tangent is opposite over adjacent, or y over x, so that's going to give us negative 1. Negative 1. At 0, our tangent is 0. At pi over 4, again, it's going to be root 2 over 2 divided by root 2 over 2, which is 1, positive 1 though. And then we get up here to pi over 3, and now we're back to being undefined. Okay, so our 0 is at 0 radians. Our positive negative 1 is at pi over 4, negative pi over 4, and then our asymptotes are at negative pi over 2 to pi over 2. And our period, what is the period of cotangent tangent? The period is pi for both tangent and cotangent. Now for tangent, okay, we're going from undefined to undefined. So for tangent, the endpoints are negative pi over 2 and pi over 2. Okay, let's go over here to cotangent real quick. Now again, we want to go from where it would be, where it's from undefined to undefined, so where we have asymptotes. So here, if we come around, at pi over 2, cotangent is 0. At negative pi over 2, cotangent is 0. Now, cotangent at 0 radians, that would be undefined. And the other place where it's undefined is right here at negative 1, 0. So now for cotangent, we're dealing with the first and second quadrant, and we're dealing with 0 to pi. And then again, we're going to split this up into pi over 4, pi over 2, and 3 pi over 4. So that's here, 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 and here. So that's our cotangent moments. All right, so at 0 radians, it's undefined. Oops, x, y. Undefined. And then at pi over 4, this is at 1. At pi over 2, cotangent is 0. At pi over 3, because this is negative root 2 over 2 and root 2 over 2, which is negative 1. And then it's undefined here. All right, so over here, the cotangent endpoints, again, it's the period is pi, 0 to pi, but the endpoints are 0 and pi. So a little bit different there. Okay, how can we easily use the amplitude? Amplitude comes from the coefficient of the function. So we already know this, I think. So amplitude comes from the coefficient of the function. What do I mean by that? Well, for example, let's say we have f of x equals 2 tangent x. All right, this is going to be my amplitude, which is like the same. But the amplitude is only going to affect, really it's only going to affect these two values. Okay, it doesn't really affect this because this is 0, but we kind of say it affects all three of those, but we don't really care about what's undefined. So we're going to see that, but we do actually have amplitude that we have to deal with. All right, so let's go with the parent function of tangent. Amplitude of the parent amplitude is going to be 1. The period is going to be pi over b, and in this case, it's just pi. The endpoints are going to be negative pi over 2 and pi over 2. Okay. We get the midline. We do have midline to think about. And in this case, the midline is y equals 0, the axis, the x-axis. Okay, other things we have, we could look at key points. Same idea before, that those key points or those integrals, key points. And we do the same thing we did before for key points. We take our period, whatever your period, I shouldn't put pi there. I mean, pi is our period, but that may change. So endpoints are period, because the period might change, divided by 4. So for the parent function, that will be pi over 4. All right, so let's see what this graph looks like. We can make the table again if we want to. We don't really have to. We know it. In fact, I'm going to just, oops. So endpoints, we have asymptotes at our endpoints. So here to here. And notice that's 1 pi. Okay, at 0, 0 is 0. Again, if we want to go back up and look at all right. And then at pi over 4, negative pi over 4, we were at negative 1. And then at pi over 4, we were at 1. Okay, so it looks like that. Okay, that would be one period. Now again, we can go out here and we could keep drawing it out. We could make another asymptote here. We could come here, make another asymptote. Okay, and then we could draw these out here, here, here. So it's always that middle point, and then 1 to the right, 1 to the left, plus 1, minus 1. Now, if the amplitude changed and it was 2, then we would be looking at it up here, but we'll get to that later. So let's just go ahead and see what this looks like. So this would come down. All right. If we want to do it over here, same thing. Okay. If you wanted to fill the whole graph, you would come here, and you would do this, and you would do this, if you want to fill the whole graph. But this right here is one period from asymptote to asymptote. Okay, we can look at cotangent, same idea. Of the parent function, the amplitude is 1. Okay, the period, again, the period is pi over b, and in this case, that would just be pi. The midline, there's no plus d here, so the midline is, again, y equals 0. The endpoints. The endpoints are from asymptote to asymptote, so for cotangent, that's 0 to pi. And then key points, just like we talked about before, that's the period divided by 4. So in this case, it would be pi over 4. So very similar, but our graph will look a little bit different. So we have an asymptote at 0. That's one of our endpoints here. And then out to pi here. At, let's see, come back here. At pi over 2, it's at 0. Okay. At pi over 4, it's at 1. And at 3 pi over 2, it's at -1. So it looks something like this. And what you should notice, let me go ahead and draw a couple of these out here, just so you can kind of get the idea. We come over here, negative pi. Oops. There. Okay. Well, you will notice between tangent, cotangent, they look very similar, right? They're this line, that middle point, the middle in between the two asymptotes, that middle point crosses the midline, wherever our midline is. And then you go halfway from that middle of our graph to the asymptote. Halfway between there is where you'll then draw your amplitude. You'll notice with tangent, it's going from from upper right down to lower left, upper right down to lower left, whereas with cotangent, we're upper left going down to lower right. Okay, so they kind of look almost like a reflection of each other, which makes sense because they are, okay. Going to go through and do some practice ones, but I'm going to stop the video now to take a break.